Welcome back to NDE HealthTech Academy. I'm Alexis ND, co-founder of NDE HealthTech Solutions. In our previous lesson, we explored the COMS framework and learned the 5 principles that help organizations build high-performing DevOps cultures. Today, we're taking the next step. We're going to answer one of the most common questions asked by both beginners and hiring managers. Who actually does what in a DevOps team? Modern software delivery isn't the responsibility of just one person. It requires an entire team of professionals working together toward a common goal. Developers write the code, quality assurance engineers test the application, DevOps engineers automate software delivery, cloud engineers build and manage the infrastructure, security engineers protect the environment, and site reliability engineers, often called SREs, keep systems reliable, available, and running smoothly. By the end of this lesson, you'll understand the responsibilities of each role, how they collaborate throughout the software development lifecycle, and why every role is essential to delivering secure, reliable, and scalable software. So let's get started. Before DevOps became popular, most organizations followed a traditional approach to software development. The process was simple. Business analysts gathered the requirements and handed them to the development team. Once the developers finished writing the code, the application was passed to the quality assurance team for testing. After testing was complete, the operations team deployed the software into production. At first, this process seemed organized, but there was one major problem. Each team worked independently with very little communication between them. Every handoff introduced delays. Misunderstandings became common. Software releases took weeks or even months, and if a major problem was discovered late in the process, the entire cycle often had to begin again. DevOps changed that model completely. Instead of working in separate departments, developers, quality assurance engineers, DevOps engineers, cloud engineers, security engineers, and site reliability engineers, or SREs, worked together throughout the entire software development lifecycle. Automation replaces repetitive manual tasks. Feedback is shared continuously, and every team member shares responsibility for delivering reliable, secure, and high-quality software. The result: organizations release software faster, improve quality, reduce downtime, and respond much more quickly to changing business needs. Now let's begin exploring the individual roles within a DevOps team. Starting with the developer. Developers are the people who build the applications we use every day, whether it's a banking app, an online shopping website, or a hospital's patient portal. It all begins with the developer. Their primary responsibility is to transform business requirements into working software by writing clean, efficient, and maintainable code. But writing code is only part of the job. Developers also test their applications, identify and fix bugs, improve performance, and continuously refine the user experience. Modern developers rely heavily on Git, one of the most widely used version control systems in the world. Git allows developers to safely track changes, collaborate with teammates, review code through pull requests, and manage multiple versions of an application without losing previous work. Developers also integrate their applications with databases, application programming interfaces, or APIs, cloud services, and many other technologies that support modern software. Throughout the development process, they work closely with quality assurance engineers, DevOps engineers, cloud engineers, and security engineers to ensure the application is ready for deployment. In a modern DevOps culture, developers don't simply write code and hand it off to another team. Instead, they share responsibility for delivering software that is reliable, secure, and scalable, all the way into production. Let's look at a real-world example. Imagine a hospital wants to introduce online appointment scheduling for its patients. The developer designs the feature, writes the application code, tests it thoroughly, and commits the finished code to the shared Git repository. From that point, the automated DevOps pipeline takes over, building, testing, and preparing the application for deployment. Every successful DevOps project begins with developers building high-quality software that solves real business problems and creates value for users. After developers build new features, the next critical role is the Quality Assurance Engineer, often called the QA Engineer. The primary responsibility of a QA engineer is simple: to make sure software works exactly as intended before it reaches users. Their job isn't just to find bugs, it's to prevent those bugs from ever reaching production. To do that, QA engineers begin by reviewing the business requirements and creating a testing strategy. They design test cases, perform manual testing, and verify that every feature behaves correctly under different conditions. In traditional software development, testing usually happened near the end of the project. But in a DevOps environment, testing happens continuously throughout the entire software development lifecycle. This is where test automation becomes incredibly important. QA engineers create automated tests that run every time a developer submits new code. These automated tests quickly identify problems, reduce human error, and provide immediate feedback to the development team. They also perform regression testing to make sure new features don't break existing functionality. They conduct performance testing to verify the application can handle thousands of users and heavy workloads, and they perform security testing to identify vulnerabilities before the software is released. Let's look at a healthcare example. Imagine a hospital is introducing a new online prescription refill feature. Before patients ever use it, QA engineers verify that prescriptions are submitted correctly, patient information remains secure, and the application continues to perform reliably even during periods of high demand. In a DevOps culture, quality isn't owned by just one team. Quality is everyone's responsibility. QA engineers work closely with developers, DevOps engineers, product owners, and security teams to ensure every software release is reliable, secure, and ready for production. At the heart of every successful DevOps organization is the DevOps engineer. While developers focus on writing software and quality assurance engineers or QA engineers focus on testing, the DevOps engineer is responsible for automating and managing the entire software delivery process. Their mission is simple: move software from development into production as quickly, as safely, and as reliably as possible. One of their most important responsibilities is building and maintaining continuous integration and continuous delivery, commonly known as CI/CD. Every time a developer commits new code, the CI/CD pipeline automatically builds the application, runs automated tests, performs security checks, and prepares the software for deployment. Instead of waiting days or weeks for a release, this entire process can happen in just a few minutes. DevOps engineers also manage infrastructure using infrastructure as code, often abbreviated as IAC. Instead of manually creating servers, configuring networks, or provisioning cloud resources, they define everything in code. This makes environments consistent, repeatable, and much easier to maintain. You'll often see DevOps engineers using tools such as Terraform or Amazon Web Services CloudFormation to automate infrastructure deployment. Automation is at the core of everything they do. By automating software builds, deployments, monitoring, and routine system administration tasks, they reduce human error, improve reliability, and allow development teams to deliver software much faster. Their responsibilities don't end after an application is deployed. They continuously monitor applications and infrastructure, configure alerts, analyze performance, and work closely with developers, cloud engineers, security engineers, and operations teams to resolve issues before users are affected. Let's look at a healthcare example. Imagine a hospital is releasing an update to its patient portal. Instead of manually deploying the application, the DevOps engineer starts an automated pipeline. The application is built, hundreds of automated tests are executed, security scans are performed, the application is deployed to the cloud, and the system is monitored in real time to verify that everything is operating correctly. This entire process happens automatically. allowing hospitals to deliver new features faster while maintaining security, reliability, and compliance. This is why DevOps engineers have become one of the most valuable roles in modern technology organizations. They bring together automation, cloud technologies, collaboration, and operational excellence to help organizations deliver secure, reliable, and scalable software faster than ever before. Once a DevOps pipeline has successfully built, tested, and deployed an application, that application needs a reliable place to run. That's where cloud engineers and platform engineers come in. Cloud engineers are responsible for designing, building, and managing the cloud infrastructure that powers modern applications. Whether an organization uses Amazon Web Services or AWS, Microsoft Azure, or Google Cloud Platform, cloud engineers ensure applications remain secure, highly available, and capable of growing as demand increases. They create virtual machines, configure storage, build secure networks, manage databases, set up load balancers, and implement identity and access management services that protect organizational data. Platform engineers have a different but equally important responsibility. Their goal is to build standardized platforms that make it easier for development teams to create, test, and deploy applications. You'll often see platform engineers managing technologies such as Kubernetes, the world's leading container orchestration platform, container platforms, internal developer portals, and infrastructure as code, or IAC. These technologies allow organizations to create consistent, automated, and repeatable environments for every application. Platform engineers also monitor cloud resources, optimize infrastructure costs, and build self-service platforms that allow developers to request infrastructure in minutes instead of waiting days for manual approvals. Let's look at another healthcare example. Imagine a healthcare organization is launching a new telehealth application. The cloud engineers design a secure, highly available cloud environment that protects sensitive patient information and keeps the application running 24 hours a day. At the same time, the platform engineers provide the Kubernetes platform, deployment tools, and automated infrastructure that allow developers to release new features quickly, consistently, and with minimal downtime. Together, cloud engineers and platform engineers provide the foundation that supports every other DevOps role. Without reliable infrastructure, secure cloud services, and well-designed platforms, even the best applications cannot operate effectively. As applications move into production, two additional roles become essential: the Site Reliability Engineer, often called an SRE, and the DevSecOps Engineer. Although these roles have different responsibilities, they share one common objective: keeping applications reliable, secure, and available for users at all times. Let's begin with the Site Reliability Engineer. SRS focus on keeping production systems healthy and performing at their very best. They continuously monitor applications, respond to incidents, and work to prevent outages before customers are affected. To measure reliability, SREs define important performance targets such as service level indicators, or SLIs, service level objectives, or SLOs, and error budgets. These measurements help organizations understand how well their systems are performing and how much risk is acceptable while delivering new features. When something goes wrong, SRS investigate the root cause, restore service as quickly as possible, and perform post-incident reviews so the same problem is less likely to happen again. Now let's look at the DevSecOps Engineer. The name DevSecOps combines three disciplines: development, security, and operations. Instead of treating security as the final step before deployment, DevSecOps integrates security into every stage of the DevOps lifecycle. DevSecOps engineers build security directly into the continuous integration and continuous delivery, or CI/CD pipeline. They automate vulnerability scanning, dependency analysis, secrets management, compliance verification, and cloud security validation. Their goal is simple: identify and eliminate security risks as early as possible, reducing both cost and security exposure. Let's look at a healthcare example. Imagine a hospital is deploying a new patient portal. While the DevOps pipeline automatically builds and deploys the application, the DevSecOps pipeline scans the source code for vulnerabilities, verifies HIPAA compliance, checks cloud security configurations, and ensures sensitive patient information remains protected. At the same time, the SRE continuously monitors system performance, tracks availability, and responds immediately if any production issue occurs. Together, site reliability engineers and DevSecOps engineers ensure applications are not only delivered quickly, but also remain secure, reliable, and resilient throughout their entire lifecycle. Now that we've explored each role individually, let's see how they all work together in a real-world healthcare project. Imagine a hospital wants to introduce a new online appointment scheduling system. Patients will be able to schedule appointments directly from their computer, tablet, or mobile phone. The project begins with the product owner. The product owner gathers requirements from hospital leadership, physicians, nurses, and clinical staff, then works with the development team to prioritize the features that deliver the greatest value. Next, the developer designs and builds the appointment scheduling feature. They write the application code, perform unit testing, and commit the completed work to the organization's Git repository. The moment that code is committed, the continuous integration and continuous delivery, or CI/CD, pipeline automatically begins. The quality assurance engineer validates the new feature by running both automated and manual tests, making sure everything functions correctly and meets the organization's quality standards. Once testing is complete, the DevOps engineer manages the automated pipeline that builds the application, performs additional validation, packages the software, and prepares it for deployment. Next, the cloud engineer and platform engineer provision the cloud infrastructure, configure networking, storage, databases, Kubernetes resources, and every platform service needed to run the application securely and reliably. Before the application is released, the DevSecOps engineer performs automated security scans, checks for software vulnerabilities, verifies HIPAA compliance, reviews cloud security configurations, and ensures sensitive patient information remains protected. Once the application is live, the Site Reliability Engineer, or SRE, continuously monitors system performance, tracks availability, configures alerts, and responds immediately if any production issue occurs. Finally, the application is released into production. Patients can now schedule appointments online quickly and securely, while doctors, nurses, and administrative staff receive accurate scheduling information in real time. This example demonstrates the true power of DevOps. Every professional contributes specialized expertise, but they all work together as one collaborative team with a shared mission, delivering secure, reliable, high-quality software that improves patient care. Before we finish today's lesson, let's take one final look at the complete DevOps team. One of the biggest misconceptions about DevOps is that it's a single person's job. The truth is, DevOps is a team effort. Every professional brings unique skills, but they all share one common objective: delivering better software to users. The product owner defines the vision, gathers business requirements, and prioritizes the work that delivers the greatest value. The developer transforms those ideas into working software. The quality assurance engineer ensures every feature is thoroughly tested before it reaches production. The DevOps engineer automates the software delivery process, allowing organizations to release applications quickly, consistently, and reliably. The cloud engineer and platform engineer provide the secure, scalable infrastructure that modern applications depend on. The DevSecOps engineer integrates security throughout the entire development lifecycle, helping identify vulnerabilities before they become serious problems. And the Site Reliability Engineer, or SRE, keeps production systems healthy, available, and performing at their best. When all of these professionals work together, organizations release software faster, improve quality, strengthen security, and deliver better experiences for their customers. If there's one message I want you to remember from today's lesson, it's this. DevOps isn't just about automation. It isn't just about cloud computing. And it certainly isn't just about tools. DevOps is about people collaborating, communicating, and working together to deliver value. Whether your goal is to become a developer, a cloud engineer, a DevOps engineer, a cybersecurity professional, or a platform engineer, understanding how these roles work together will make you a stronger technology professional, and that's exactly what DevOps is all about. Before we move on to our next lesson, let's take a few moments to review what you've learned today without looking back at your notes. See if you can answer these questions. Who is responsible for defining the product vision and prioritizing the work? Which role writes the application code and commits it to the Git repository? Who tests new features to make sure they're reliable before they're released? Which professional builds and manages the continuous integration and continuous delivery, or CI/CD pipeline? Who designs and manages the cloud infrastructure where applications run? Which role integrates security throughout the DevOps lifecycle and helps maintain compliance? And finally, who continuously monitors production systems, responds to incidents, and keeps applications reliable? If you were able to answer most of those questions, congratulations. You now have a solid understanding of how modern DevOps teams work together to deliver high-quality software. Remember, DevOps isn't about one person doing everything. It's about developers, quality assurance engineers, DevOps engineers, cloud engineers, platform engineers, DevSecOps engineers, site reliability engineers, and product owners working together toward one common goal: delivering software that is secure, reliable, scalable, and valuable to the people who use it. In our next lesson, we'll explore the DevOps lifecycle and follow an application from the initial planning stage through development, testing, deployment, monitoring, and continuous improvement. This next lesson will connect everything you've learned today and show you how these roles work together throughout the entire software delivery process. Thank you for joining me today. I'm Alexis N, and I'll see you in the next lesson here at NDE HealthTech Academy.